we're going to be moving on to actually Emily Mishler, who is a part of Foundation for the Future. She will be talking about fundraising. Really quickly, Emily is actually, she actually specializes in business development, creative strategy, and fundraising. Ms. Mishler launched her first company at the age of 22 and has since raised and distributed over $20 million of private investment for private clients, for profit entities, and NGOs. She runs a group of impact-driven companies called the Cultivated Group and is on a mission to ignite and empower individuals and organizations to be the change you wish to see in the world. Emily, are you, oh, there you are. How are you?
I'm good. How are you, Leo?
Pretty good.
Great.
So if you want to go ahead and lead from here, I'm going to pull up my screen and present whenever you're ready, okay?
Wonderful. Thanks so much, Leo. And well, you all, it's a pleasure to meet you and I'll be here today. My name is Emily Mishler, and like Leo said, my background is the intersection of corporate philanthropy and creative solutions for revolutionary ideas. I've recently become affiliated with the Foundation for the Future, and from the nonprofit perspective, have become a partner in building the development arm of the operation. So what does that mean? That means we're financially positioning the foundation to be able to continue this important work for years, if not generations to come. And the time is now. From our conversation today, it's abundantly clear our work is disruptive, and that means we need your help. I've been both incredibly impressed with the comprehensive vision, expertise, dedication, and momentum of the speakers today, and the vision of the Foundation for the Future, the powering force behind Blue Marble Week. I believe we can all agree that the future the Foundation is building is inspiring and worth investing in. This future, in space and beyond, is being built one relationship, conversation, and connection at a time. In order to continue this momentum and building and contributing to this caliber of event, conversation, and community, we need your help. We need you, our allies, attendees, partners, advocates, and friends, to spread the word about our important work through social media, invite like-minded and like-hearted peers to our events, and to help connect us with philanthropists and organizations who believe what we believe, that our future in space is ours for the building and the time is now. We're so excited to announce 2 different avenues to become involved if you're interested in financially supporting our work. On a corporate level, we have the opportunity to sponsor Blue Marble Week and the Foundation for the Future at large on a monthly and annual basis to support this work. On a personal level, if you, your friends, or family are inspired to support us, we welcome your contributions to support building space infrastructure and economy. More information for both opportunities is available at the Foundation for the Future's website, f4f.space, or by scanning the QR code on the screen. So our ask, help us bring space home, because the time is now and the world can't wait. If you have any questions, please don't hesitate to reach out to myself, Lila, Tim, Leo, or any affiliate of the Foundation for the Future. Our contact information and the link to donate is available, like I had mentioned, at the QR code available on the screen and is also on the website. I'm happy to stick around and field any questions, and thank you so much. And now, if there aren't any questions, I'll turn it back over to Leo for our regularly scheduled programming.
Thank you so much, Emily, for that. And again, Emily is a part of our team here at Foundation for the Future. You can get more information, like she said, at f4f.space. Thank you so much, Emily. We'll actually be having her a part of a panel, so you can catch her on. It'll be that'll be coming up tomorrow at...
Yeah, it's tomorrow at noon Eastern time.
Awesome. So you'll get more information then. We're going to be moving on to our next speaker. Our next speaker after Matt Banky is Ryon Stuart. Ryon Stuart is actually going to be talking about open innovation development. Ryon Stuart serves as the challenge coordinator at NASA Center for Excellence for Collaboration Innovation. He is responsible for fostering the use of open innovation tools at NASA and other parts of the federal government and coordinates crowdsourcing projects for multiple agencies. His career at NASA included hands-on experience in operations facilities, engineering, GN&C, robotics, and ISS Flight Operations, including over 2,200 hours of real-time execution of ISS activities. He also worked as an instructor for the ISS Motion Control System. Ryon has an Aeronautics and Astronautics Engineering degree from the University of Washington. Ryon, thank you so much for being here. The screen's yours.
Awesome. Thanks. Let me present my screen here. All right. Hello, all. as I said, my name is Ryon Stuart. I work for NASA's Center of Excellence for Collaborative Innovation. And today, probably a little bit different topic than you've been seeing so far. We're going to talk about how NASA harnesses the power of crowdsourcing for idea generation, innovation, problem solving, and technology scouting. This can be particularly relevant to help your organizations, your companies, your technology groups take some giant leaps forward. And I hope that by the end of this, you'll understand why that's a particularly important thing. So I work for NASA's Center of Excellence for Collaborative Innovation, or COSI, you may hear me say as we call it. We were founded in 2011 at the request of the White House Office of Science and Technology Policy to form a Center of Excellence to help the US federal government utilize the skills of the general public, recognizing that crowdsourcing has some pretty significant means of moving projects forward, solving difficult problems, getting good perspective, all the things I'll talk about shortly. And so my small office operates the Center of Excellence for all 10 centers at NASA, as well as the rest of the federal government. We work with lots of other agencies currently and have done so in the past to help get really good solutions for all of the taxpayers. Publicly, we're known as the NASA Tournament Lab, and so our job is to offer contracts, mechanisms, process support, education, outreach, and research in the open innovation and crowdsourcing space. If any of this is unfamiliar to you, like to most people, hopefully by the end you'll understand pretty well what I'm talking about. But let's get going. So one quick note is I don't have the time that I usually do to present this kind of information. Usually I'll spend like over 30 minutes really just making the case for innovation. I think that's a huge part of understanding why this is important. So I'm going to try to boil that down a little more today, but certainly I'm still going to spend a good bit of time on making the case to innovate before we really talk about what specifically NASA is doing. So at NASA, we have some pretty big goals, and frankly, these goals probably align with most of you that are on today, of trying to explore for the betterment of humankind, right? And in order to do the things that we want, we need more affordable propulsion, long-term human habitation, communication over very long distances, galactic cosmic radiation protection. These are things that we are very unlikely to achieve in the near term using traditional methods, right? We need some giant leaps in order to reach these goals that we have to do the exploration that we want to do. And honestly, if you want to make giant leaps in innovation, you just normally can't keep doing things traditionally. It just takes a long time. Usually the types of gains that you see are very incremental. And that's just how work is usually done. So we recognize that if these are our goals in the future, we have to come up with a plan to get there. And traditionally, NASA, as well as most other large organizations, use kind of this funnel method when you're thinking about strategic investment, strategic development. And so you start off at the beginning in a discovery phase where you spend a little bit of money on lots of technologies trying to figure it out, which of these fits the bill for what we're doing. And as you figure out and filter out different technologies, you spend more and more money until you get into development. And you spend a bunch of money on whatever that technology is that you're trying to produce. But I want to say the world has changed, and this is not hyperbole. I'll give you plenty of examples as we move forward. And so what's worked for us in the past may not work in the future, and frankly, a lot of it won't work, and I'll show you why. So one stat that many people don't realize is that 90% of every scientist that's ever lived on our planet is alive right now. Like most of these that you see here are famous, and you should recognize most of them, but most of them are not alive. But 90% of every scientist that has ever lived is alive today. And you can see in the number of patents worldwide, the number of PhDs granted worldwide over time, that in the past even 10 years, because of this giant exponential growth, we see significantly different numbers of people working on hard problems than we used to. And in conjunction with this, we see a lot of these what we like to call technology building blocks, which are accelerating change. And none of this should be unfamiliar to you, but maybe it hasn't been put in one slide before. But if you consider things like additive manufacturing, blockchain, open API, software, machine learning, cloud quantum computing, etc., these technologies have a few benefits that are drastically impacting how quickly we're able to innovate. One is that they're cross-domain. So you think of all these technologies, they're not just in one space. They're in lots of spaces. And what's great about that is when one domain innovates, the other one can learn from that and continue to move, and they innovate, and they all grow. we see this huge, it's adding to the exponential growth. The other side of that is these technologies are all extremely accessible. It used to be not that long ago that if you wanted to learn about where technology was going to grow and what, what the future looked like in the next 5 years, you could go to your big organizations, GE, Microsoft, those ones, and those were the only ones who could innovate. Now, someone across the world can buy a 3D printer and they can work on it in their garage and they can innovate. And that means that lots of people are working on lots of technologies and innovating on lots of great things. There's some pros and cons to this, though. The pro is very obvious. We have amazing new technologies that can result in significant gains towards solving hard problems. The con, though, is that it's becoming incredibly difficult to find the number of technologies and solutions growing across all of these sources, right? How do you find that person who's innovating on the 3D printer on the other side of the world? And there's consequences to this, which many people don't realize. So let's go back to how we operate normally at NASA, traditionally, how many organizations operate is right back to this funnel method. So we go back to the discovery phase and we see that there's now way more solutions than there used to be, way more possible technologies in the discovery phase than there used to be. And we don't even see most of them, right? They're not just at the trade shows, like I said, they're all over the place. And there's consequences to not seeing them. Odds are, if you don't see it, you're going to end up missing key technologies by the time you get to your development phase. And if you're spending lots and lots of money and you're missing key technology, that can have some pretty big consequences. Competitors who may or may not have found that could be significantly ahead of you. And what do you do when you're a couple years into a 10-year program and it turns out that you spent a bunch of money, but you're missing the key technology that your competitor didn't miss? That's not a good place to be if you're a program manager, that's for sure. So in summary of that, we see that the rate of change of knowledge and technology is increasing drastically, but it's hard to find skills and expertise. It's really hard to keep up with technological advances. And frankly, we're at high risk to remaining competitive and relevant. Many people would think that this only really applies to the private space, where it's absolutely true, but they already usually tend to know that. But it's true in the public space, it's true in the global space, right? You have to think of, if an organization like SpaceX or Blue Origin, right, they're landing boosters and NASA's not, then the public taxpayer may say, well, what's my money going towards? So perception is extremely important as well. And there's no doubt that we're doing very innovative and very good things, but it's important that we continue to innovate so that we're even perceived to be doing the right things. Now, I'm going to give you what we have found as a very valuable solution to these problems, and then I'm going to explain why that's the case. And what we found is open innovation or crowdsourcing. They're bringing together and curating large numbers of people from all around the world, all types of background, skills, expertise, able to provide very valuable products and services. And it has really operated as a solution to keep pace with this accelerating change. And I'll explain why. So before I get into a few of the real nitty-gritty reasons of why crowdsourcing works so well, I want to first define what I mean by curated communities. And frankly, let me also define open innovation, because that's a term most people aren't familiar with. So the concept of open innovation is really not always holding everything in, right? So you think of R&D for most companies, it's all proprietary. They don't want to share any information. They don't want to lose any any of their competitive advantage. The concept of open innovation is picking and choosing your right spots to open up part of your research and development, open up part of your technologies to the public in order to bring in their great ideas back into your organization to give you a better launching point to move forward. And so crowdsourcing is a form of open innovation. We tend to, within the NASA Tournament Lab, utilize curated communities, which is likely also a term you're not familiar with. And a curated community is really kind of two-sided. It's crowd-facing and customer-facing. And so when we, within the NASA Tournament Lab, have a problem, so let's say someone at NASA, some other government agency comes to us and say, hey, we have this engineering problem, a science problem, or whatever it is, we need a piece of art design, whatever the thing is going to be. They come to us and we contract with one of the companies that we already have on contract. We set up with them to work with their crowd, their curated community, to get a good solution. And so we work with all these different vendors who owned their own large crowds of folks around the world. And so there's kind of two sides to that. One is that they're crowd facing. And so these companies like HeroX, Freelancer, Topcoder, Vanguard Health, GrabCAD, I'll explain all the companies we have later. These are just some examples. They draw in members from all around the world, usually around a passion or an interest. And so they're curating this crowd based on some particular niche, right? They're really interested in problem solving, engineering designs, or software coding. And Topcoder is a very good example. They have about 1.5 million software coders, about a third of those being data scientists. And so it's some of the best software coders in the world, but probably some of the worst software coders in the world are all joining this crowd because they want to solve hard problems. Maybe they want to make money. They want to, they want to help organizations move forward in software coding, or maybe they just like the social aspect of it. But they get on there because they're interested in software coding. And so companies like Topcoder are drawing their members in based on that passion or interest. But these companies are also customer facing. So when NASA comes to them, when Google, when Facebook, when Comcast Xfinity, all of these are using crowdsourcing, companies like that come to them, these organizations here understand their crowds better than anybody else. And so they can curate parts of that crowd or the wholes of the crowd, or they can bring in more crowd members, and they can tweak our problems just right so that they can provide the most value back to the customer, in our case, NASA. So let's talk a little bit about why this works. So this is just a theoretical problem. If we get posed to the general population, X being level of expertise, skill, your Y-axis being people. So let's just say we have a NASA type problem posed to the population. We would expect that generally the general population is not going to know too much about it as compared to a NASA or as NASA at our organization. And so you would expect that the average person somewhere around here probably has heard of the thing but doesn't know that much about it. Most people fall in that general range. There are some world-leading experts who know a ton of information, and NASA has some of those world-leading experts, right? And generally, we'll see that our organization is right-shifted. You'll see that pretty much anywhere, right? Because most people will try to hire folks that understand better than average what that problem is. But what we don't often recognize is that our organizations are always very small compared to the general population. NASA specifically, which is much bigger than probably any of the organizations you all have, is about 60,000 people, and that's civil servants, contractors, engineers, scientists, admin, whatever. So we are certainly smaller than the general population. And what you find there is that there's an inherent high-value expertise skill green wedge that has as good or better solutions to any given problem than we do. It's really a numbers game. And so if there's a way to access that, then you can get really good solutions that at NASA, we have great solutions, but we can't have all of them. It's not possible to have all of them because we just don't have enough people to do that. What we also see is that these curated communities themselves are right-shifted because they're folks that join these crowds because of a given interest or passion, and so they understand more than general population. And because they're so large, often in the hundreds of thousands or millions of people, they cover a significant more portion of that high-value expertise wedge than any individual organization will typically do. So let's talk about how crowds can cut across a broad set of technical disciplines and what that really means. And so let's say we pose a problem to a crowd and it's in the computing space. And so we'll see that maybe we get 4 really good solutions back, and we will always see that they come back from all kinds of different domains. Somebody that's an expert in the computing space, given that this is a computing problem, may very well give us a really good answer, right? Someone that's just top notch, and they happen to be part of this crowd, they saw it, and they can give us a really good solution. That happens sometimes. But we also might see that we could get great solutions from completely different domains. And as we'll see on the next slide, that actually happens more often than not. But one thing that's really interesting and many people don't realize is that for crowdsourcing to really work, you don't even have to be within the domain or even the best in your own domain to solve that problem. Somebody in the automation space who may be worse than average in automation can provide a very valuable solution to the computing domain because they need to have just the right background and skills and expertise to kind of translate something that's normal and obvious in the automation space into the computing space. And that's what's great is we don't require the best of every domain. We just require someone who can put the two together, break through those silos in order to provide valuable information. In fact, there's a study done on this. So Innocentive is the name of a contractor, a company who has a crowd. In fact, they were a previous contractor of ours within the NASA Tournament Lab. And so some research was looked at where they were looking at successful challenge solutions coming out of Innocentive. And they found that 70% of those successful challenge solutions were solved by individuals outside of the challenge's specific technical domain, right? So if you have a difficult chemistry problem and you say, here, two great chemists, go solve this problem, you're already doing it wrong. 70% of the time when the problem was posed to a broad crowd, it was solved by somebody outside of that domain. And part of that reasoning is because 75% of the time, the successful solvers already knew the solution to the problem when it was posed. That means that innovations aren't what we often think of them as this light bulb idea from a genius. It's more often than not coming from someone who already knows the answer. They just didn't know that the question existed. They didn't know that you were having that problem. Somebody in the computing space and somebody in the automation space didn't know they needed to talk to each other and didn't know how to talk to each other. And crowdsourcing allows them to do this. And I'll explain how we get to that point in a second. First, I want to go through two industry examples. Neither of these examples are through NASA Tournament Lab. I think they do a really good job of being very digestible to understand some of the benefits of crowdsourcing. Both of these are real examples. They just happen to not been through a NASA Tournament Lab. So this first is a potato chip problem. So a potato chip company was looking to remove grease from potato chips. So they decided to crowdsource that problem because they couldn't figure it out internally. And so the crowdsourcing company, the first thing they did was generalize the problem for a broad crowd, which is a very important step often in the crowdsourcing world. Because if we only wanted answers from the food production folks, then we're very likely only going to get the same kind of answers we've always had. And so you're not going to see the big gains that they're looking for. And so by changing it from remove grease from potato chips to remove a viscous fluid from a delicate wafer, you've generalized it. And now no one even realizes that it's a potato chip problem, right? This is also an advantage if you're looking for maintaining competitive advantage and not letting others within your domain know that you're working on these problems, or even letting the solvers know that they're solving a potato chip issue. So the existing solution was to mechanically vibrate the chips to shake off the cooking oil, probably designed by mechanical engineers who are experts in vibrations. And they've been doing the same thing for a long time. But as you know, often in the bottom of the bag of the chips, there's little pieces, and for whatever reason, us humans only like the big chips, and so they want to get rid of that waste. The new solution was to acoustically vibrate the air around the chip at a frequency such that it causes the oil to separate from the chip. Very elegant solution. It was awesome that they got something so good out of this crowdsourcing competition. But just as interesting as the solution, which will probably completely change how potato chip companies dry their chips, is where it came from. An unexpected solution source, and we see this all the time, which was a violinist, which you can argue is an adjacent domain expert, because the violinist is also an expert in vibrations, just a very different type of vibrations. When a violinist is playing the violin, they see the rosin come off their bow. They're working with harmonics all the time. And so the concept of waves and using vibrations in a completely different way was something the violinist already knew when this problem was posed. Just no one had thought to ask the violinist, who had this perfect background of knowledge and expertise, to apply a solution to the problem for the potato chip industry. All right, cool. One other case study here for you. So some folks at Harvard started to recognize that, particularly in the algorithm data science world of crowdsourcing, they were seeing really good solutions almost every single time, getting very consistent large gains. And so they started to think, are companies like Topcoder, Kaggle, those others that do the algorithm crowdsourcing world, do they just happen to own some of the best, or not, sorry, own, do they happen to have on, as part of their crowd, some of the world's leading experts? Or is it, and we're just kind of using this as a new subcontracting model, or is crowdsourcing really providing a benefit? So they took the National Institutes of Health Megablast algorithm, and they use this as a case study. You don't need to know anything about the algorithm other than what I have on the graphic, which is it has an accuracy of 0.72 points. It took a little over half of a workday to run, and multi-year development was put into this in the first place. So the first thing they did was they assigned a full-time resource. This is pretty close to your traditional method of getting work done. And so that full-time resource was given $120,000 and 1 year of development. This full-time resource was, I think, a couple just graduated from school, leading data scientists who were at the top of their game, understood the technology really well. They did a really good job. They knocked down the time to 47 minutes and the accuracy up to 0.77 points. So like an order of magnitude better in time. And so they did a particularly good job. Then they ran a 2-week contest on Top Coder. So 14-day for only $6,000. And they got a winning solution of 0.8 points and down to 16 seconds. And one of the things that makes this obvious, other than just that being significantly better than the baseline and the full-time resource, as you can see here, one note is that this is logarithmic in the X here. They noticed that, so the winner was way, way better, but so were these other 20 or 30 not winners, right? So some of these others would have also won prizes, but they saw that, okay, crowdsourcing really is a thing here. This isn't just 1 or 2 people that won. There's a lot of people who produce significantly better solutions. And so this kind of helped prove to the Harvard team that, yeah, this is really a benefit, not just happens that this crowd has some of the best people, but there really are significant advantages to crowdsourcing. Okay, so let's talk real quick. How are we implementing these tools and processes within NASA? How we do it within the government is very likely different than how you might do it if you're a private company. But hopefully you can see what we do and maybe model some things after that. So again, COSI works for NASA, but across the rest of the US federal government as well. So we have access to over 40 open innovation firms and communities representing over 100 million people worldwide. I can't remember the exact number, but I want to say that's like well over 1/3 of the entire US workforce in equivalent number. And so we have quite a few different contracts that's probably generally kind of boring to understand, but I do want to talk about the different types of work that we do. So we do a lot of the prizes and challenges work, which is where someone has a problem, it gets posted through one of these companies as like a prize, and there's a certain number of winners, and those winners will get paid out whatever the prize money is based on requirements. And the top type solution, the IP from that will be owned by often the user, but then the government will get a government purpose license, meaning that the government can't get charged for it in the future and can take that solution and move forward. We also use a couple other things which might be interesting, which are called technology searches. Technology searches are really good at giving you an idea of what's the state of a technology across the world, which is really good for if you think you need a solution to a problem that already exists, or if you're about to do some R&D and you want to understand, am I picking that right technology, right? Like that funnel thing we talked about at the beginning. How do I know that I'm picking the right technology at the beginning, starting at the right place? Technology searches are really good for that. Another place that's interesting is micro-purchase. We found that using a government credit card, so $10,000 or less, we can make significant gains doing like data labeling through Amazon Mechanical Turk. Lots of multimedia can be done for only a few $1,000s. So it's often we're finding the tens to hundreds of thousands of dollars for your big type problems, sometimes even up in the millions. But you can get a lot of real work done at the micro purchase level as well. One other thing I want to talk about is our internal crowd, NASA at Work. And so though none of you, if you aren't part of NASA, can operate as part of NASA at Work, I think it's an important thing to understand if you have kind of a larger organization. And so we have an internal crowd where often before we go to the public, we'll first ask NASA, kind of, what do you know? And so we have this curated crowd within NASA, about half of the NASA's on it, it's about 30,000 people, where if we have a problem, we can ask them. Because NASA is large enough that there are tons of silos, and we don't know what we already know. I can't know what somebody else at Johnson Space Center, or certainly at other centers, know about everything. And so before we move forward and spend money, it's good to know what information do we have within ourselves. One good example of that, froze here. There we go. Was a problem that we had a few years ago where one of our teammates at Johnson Space Center, Robert Petrick, was looking to come up with a better way to determine urine volume in microgravity. And so he was about to spend a good bit of money, a little over $1 million in multi-year development, doing a traditional method to get a solution. Decided last minute, hey, let's run a NASA Work Challenge. Before I do this, let's see if NASA has any good solutions. Fortunately, he did that because it turns out there was a working prototype that was developed for a completely different purpose in a lab only 300 yards away, right? It could have been anywhere in the US, but it was only 300 yards away. And he was able to use that prototype and modify it slightly and save the government and the taxpayers a bunch of money in years of development. And we see this all of the time. So the internal crowdsourcing is a real thing. If you have an organization that's large enough to have silos, I highly recommend that you look into utilizing your own team members as part of a crowd to make sure that you always capture your knowledge before you go out. But as I stated earlier, there's also really good benefits to going out as well. So just to let you know that I only have 30 minutes today, but we've done over the past 10 years over 500 projects. We've seen a 94% success rate throughout the whole time. We've captured metrics through all the different kinds of problems we've done. Success being at least incremental advancement. About a third of the time we see incremental. About a third of the time we see significant advancement. About a third of the time we see we're solving the problems, right? And the people that come to us usually have difficult problems they couldn't solve on their own. Didn't have the skill, didn't have the money, didn't have the time to solve it traditionally. So we're solving hard problems, and we're doing it almost all of the time, which I don't know if you've ever been 94% successful, but I don't think I've ever been 94% successful in any long period of work. So it's pretty cool. Cost savings almost 80% of the time, with an average cost savings of 45%. Over the past 10 years, we've saved the US government about $41 million using, as compared to traditional methods, using these tools. So this is real stuff. We have real data proving that this is real. So hopefully you all can realize that open innovation and crowdsourcing is a significantly good way to make gains for your technologies. And recognize that open innovation is the future. Innovation is not optional. If you all want to remain competitive and move forward, then you absolutely need to take advantage of the skills of everyone in order to continue to move. We're doing that at NASA. We want to continue to make giant leaps like we talked about earlier, and hopefully you can do the same. All right, questions?
Ryan, thanks so much. I know that you were really crushed for time on this. I appreciate it. Folks, he's coming back next month, and we're going to talk more. So thank you. We are going to move on to our next speaker, but we will be connecting with you soon about this, Ryan. We really appreciate it. Thank you.
Ryan, can you drop in your LinkedIn profile and any other relevant information into the chat for people to see and network with you? Because this is really important information and we want to make sure that we get this.
Sure. Yeah. I'm happy to answer questions if anyone has some. Please let me know that you saw me through this event so that I know not to ignore you. Working for NASA with an open innovation background, I get lots of people trying to add me who I don't know who they are. Yeah, I'll drop it in.
Totally.
Thank you.
Thank you so much, Ryan, for everything.